Hello, welcome everybody to this the second lecture of this course to Introduction to Mineral Processing. So, in the first lecture, we have discussed that what are the definitions of minerals and ores, but our theme of this lectures, these two lectures, as that title, if you look at it, is the importance of mineral processing. So, this lecture I will try to highlight some of the points of importance of this subject. If you look at, that is, when you have mined an ore, now how do you produce metals? So, the ores must be broken down by the action of heat. That is, you have to bring the contained metal into a molten stage, and then even the gangue materials, they have to be in the molten stage, and then we have to have a separation and we can extract the metals out of that. But that is the subject of, we call it pyrometallurgy. Similarly, many times we use some solvents to extract my metals, that is the subject of hydrometallurgy. Sometimes we use electricity, that is, or the electrical properties, and that subject is called electrometallurgy. They may be used either alone or in combination, but the most common method being the pyrometallurgical process, we call it smelting. Now, as it is apparent or as it is easily understandable that these methods, that is pyrometallurgy, hydrometallurgy and electrometallurgy, they all consume vast quantities of energy. So, when the energy consumption is very high, that means the process is very expensive. Now, imagine if my input cost, that is in the form of energy to extract the metal, is more than the metal cost itself, then what will happen? I am at a loss. So, the business not going to become sustainable. For instance, let us discuss this, a rough idea about the energy consumptions I am trying to give it. Treatment of 1 ton of copper ore, it consumes in the region of 1500 to 2000 kilowatt hour of electrical energy. 1 ton of copper ore. If we assume that the per unit cost of electricity is rupees 8 per kilowatt hour, so this will be around rupees 14,000 per ton in terms of money we will be spending. Now, normally in any copper ore, we get around 1 to 1.2% of copper. So, what will happen in that case, that how much of copper I will be able to sell after extraction and what is the money I will be getting paid out of that, that will be much less than 14,000 rupees. So, how to make this business profitable? That is what we can do. We can concentrate this 1% of copper and we can increase the relative percentage of this copper content of that ore by selectively separating the gangue materials. Then my energy cost may be reduced. I have discussed this at later stage. And you also find that the smelters are very often, they are basically located at a place where energy is cheap, where you have got access to roads, rail or ceilings for shipment of your material, because the metallurgists also they have to convert it into a product and there has to be a consumer. So, you have to transport those finished products, and basically because of that what happens, that is the cost of transportation from the remotely located mine sites to that extraction plant becomes very high. And what you are transporting? You are not transporting only the your wanted material, but you are also transporting a huge quantity of unwanted material. And what happens? So, unnecessarily you are transporting the garbage from a remote place to a far distance where the smelting plant is located, and as I said that where you have got good infrastructure, that means you have got close to your urban areas. So, you are dumping that garbage from the remotely located mine site to the locality where it is thickly populated, and that will create, and ultimately you have to throw it out, and it will also create the environmental hazards, and you are unnecessarily spending that money. So, why to unnecessary spend so much money on transporting garbage? So, the essential purpose of mineral processing is one of the purposes is to reduce the bulk of the ore which must be transported to and processed by the smelter. What does it mean? That means, if my copper ore what I have mined, if it has got 1% copper, that means you have got 99% of unwanted materials. Now, if I convert it into a 20% copper content, so it becomes only 80% unwanted material. So, you are not only concentrating that copper ore, the copper contained in that ore, you are also reducing the bulk commodity, which will save the transportation cost. And what are the other implications or other relevance of mineral processing? Now, when these processes are being carried out, that is your separation processes are being carried out at the mine site, we say the plant is as a mill or concentrator, and this enrichment process considerably increases the content value of the ore to allow economic transportation and smelting. Just imagine you have got 1% copper only and you are putting it into a furnace for melting. So, what will happen? Can you really extract copper having 1% copper contained in that ore into a smelter? Answer is possibly no, because everything has to be in molten stage. How do you take out separately your molten copper from the 99% of your gangue material? So, the metallurgist, they have done all this research and they have come out with some specified limit that we cannot pour a copper ore having a minimum copper content into the furnace. and it is solely because of the economics and also because of the existing technologies. So, it is the role of the mineral processing fraternity to employ a relatively cheap, low energy processes, low energy consuming processes to separate the valuable minerals from the waste. Otherwise, what will happen? We are adapting this mineral processing technique to reduce the cost of transportation of unwanted materials. But if my mineral processing cost itself is very energy intensive, how does it help? So, it is the responsibility of the mineral processing engineers to perform this task in an economically viable manner. Now, what sort of methods we use? When I take an ore, you have the property differences, it may be physical, it may be chemical property differences between your gangue materials, that is the unwanted minerals, and your wanted minerals, that is your ore. Which properties should we exploit? If it is chemical property differences, then we have to apply some chemical methods, and chemical methods means we have to use some chemicals to promote this separation. So, the problem will come about recycling of these additional chemicals, environment related issues, and more of a cost, that is economics. So, what is the simplest mode of separation? Now, imagine if I have two particles, that is your copper containing materials and you have got your gangue materials. If they have a density difference, can we not exploit that to have a separation? There could be differences in their hardness. So, when we break it, the relatively softer material will be much more finer sizes and your relatively harder material will be relatively coarser sizes, then we can have a separation. If they have the differences in their color, even maybe the optical property based, sensor based some techniques we can think of. So, these are all essentially dealing with the differences in the physical properties. So, essentially this mineral processing deals with mostly the separation based on these physical methods. Now, what I was trying to talk about this reducing the burden what you are transporting, I will put some numbers. Like to upgrade a copper ore from 1 to 25% metal would use in the region of 20 to 50 kilowatt per ton of energy with the existing technologies focusing more on physical property differences. So, how much of material we will be reducing for transportation purposes? The corresponding reduction in weight of around could be around 25:1. So, that will reduce the transportation cost as well as it will reduce the smelter energy consumption to around 60 to 80 kilowatt hour in relation to the weight of mined ore. So, you look at that, I have to look at that what is the input energy for these separation processes, that is separation from gangue and the wanted materials, and how much of cost saving you will be having because of certain advantages like your reduction in the bulk commodity of your for transportation purposes, your reduction in the energy consumption in the smelting processes. So, this is another importance of mineral processing. Now, we will also look at when we adapt this mineral processing techniques, that although the physical methods are relatively low energy uses, the reduction in bulk lowers melter energy consumption to the order of that used in mineral processing. So, we have to do an energy balance, but what happens when the ore grade is declining? That is why I said that what is the contained value of that and how much, it depends on how much quantity of that metal or the metal bearing minerals is there into that particular ore, that will dictate the entire economics. Now, if the ores are very low grade means metal content is less, but I have got huge amount of unwanted materials. So, this energy used in mineral processing then becomes an important factor, and that is why the many people are in research in the mineral processing area, that is to innovate some low cost techniques for separating the wanted and unwanted materials for quality upgradation of the ore. Mineral processing reduces not only smelter energy cost. Why I said that if I have only 1% copper bearing ore and if I am putting it into a furnace, it is impossible to extract that copper from that, because my gangue materials, when they are in molten stage, they will also carry certain amount of copper. So, I will be losing certain amount of copper. So, what I will be left with, that will be even very less than what I had initially, that it could be much lesser than 1%. So, there will be huge losses of my wanted material when the relative percentage of that metal into that ore is less during the smelter process, such as smelting operations also. So, when I am concentrating by the mineral processing operation, you are basically reducing the losses of this valuable mineral in the smelting process itself. That is also another benefit of having mineral processing operations. Now, many times you may have good quality ore, sufficient quantities, but you may have some deleterious impurities which makes the entire smelting operation sometimes inefficient. Like the example that if you have arsenopyrite in a tin concentrate, that is you are trying to extract tin SN, then what will happen? Now, it is very difficult to remove this arsenic in smelting process, even if you have very less amount of arsenopyrite, and the entire process produces very low quality tin metal. So, ultimately what is happening, that although your tin ore qualifies to be a very good grade, but because of some unnecessary deleterious material called arsenopyrite, the entire process becomes economically not viable. Similarly, if you have alumina content in your iron ore, which is commonly the problem of the Indian iron ores, we will discuss more detail when we talk about iron ore beneficiation, but just for the your basic knowledge now. I am telling you that because of the, if you have 4-5% alumina in your iron ore, the entire process of converting this iron ore to molten metal becomes very difficult, because the energy, input energy cost shoots up like anything. And metallurgists, that is why they have put a restriction that we should not have a alumina content more than this in my iron ore. So, who will remove that alumina? Who will remove the arsenopyrite? We try through some physical property differences, that is the mineral processing. It is the responsibility of the mineral processors. Why it is the responsibility of mineral processors to separate that? Because it is the most economically viable route. You try to find out that whether we can separate arsenopyrite from my tin ore, or whether I can separate alumina bearing material minerals from my iron ore in an economically viable manner. Now, even during the mineral processing operation, you must be very careful that during this mineral processing operation, when you are breaking the particles, because as I said that first the second step of any mineral processing operation is comminution. That is, you have to break the material to free them from one another. That is, your gangue and your wanted material has to be in the, to some extent, in a free state to enable separation based on their physical property differences. But that also consumes energy, and there will be losses during this milling operation. So, the losses to tailings are one of the most important factors in deciding whether a deposit is viable or not. What does it mean, the tailing? Tailing means what we are throwing out in a mineral processing plant. We say that as of now, this quantity of material does not have adequate amount of valuable minerals to extract the metals. So, we either dump it somewhere or we use it for some other applications. So, does the tailing is free from your valuable mineral always? No, you will be losing some wanted material into the tailings also. So, that is also losses. How much you will lose? That depend on the geological formation of that particular deposit. That means, what are the mineralogical behavior of that? How my wanted and unwanted materials, they are basically oriented into that particular matrix. What are the grain sizes, individual grain sizes? So, the losses will depend very much on the ore mineralogy and dissemination, and on the technology available to achieve efficient concentration. This is a very important point. What is the availability of the technology? We always try to evaluate an ore based on the existing processes. That means, I first try to see that what are the physical property differences and whether my existing processes they can handle it. So, that is the common job of a mineral processor. But many times we say that this ore cannot be upgraded. So, for example, like your chromite processing plants, even in the tailings we are losing around 16% of Cr2O3, because at a very fine size ranges, because we say that with the existing technologies it is not economically viable to further upgrade it, and that is where the research for new technology development is required. And this is a great example that how the innovation can change. In the year 1900, a technique or a process called froth flotation technique was developed in Australia, and it helped, this process itself helped to upgrade many ores as per the requirement specified by the quality requirement specified by the metallurgist through this process, which were earlier used to be discarded because there is no technology available. And friends, there is a very relatively new subject, engineering subject, and the importance of mineral processing will be much more felt with the new innovations. So, with this basic knowledge during this course, I think some of you will be motivated to put your mind in developing new technologies, in making some of our natural resources to be economically viable to qualify as an ore. Thank you very much.